Okay, welcome back. This is the easiest section in the entire book, if you ask me. We basically have one theorem, we apply it, we get our answers, and that's that. So, yeah, I hope you're looking forward to it. So, this is kind of your generic ODE and generic solution. We just look at the first order, one-dimensional ODE, and it's linear. So, we've got our little forcing term here, we've got our little function m, and there's our zeroth order term and our first order term, and we have a solution. It's given by the exponential to the antiderivative of m times a constant. There's our homogeneous solution. And then the antiderivative of the exponential from s to t of the scalar function m, and then multiply by f, and then you retake the antiderivative of that. So that's about it. You get it as a direct result from theorem 6.5.5, but we're just in one dimension. So, I mean, everything is a commutative matrix in one dimension. So that's really what's going on there. I have a remark here, which is kind of the better way to phrase this. We first just consider the antiderivative as capital M. So we take whatever function is multiplying the first order or the zeroth order term. We take its antiderivative and call that capital M, and then our solution is given by e to the capital M times in parentheses a constant plus the antiderivative of e to the negative m. That's right, e to the negative m, and then f of s ds. So there you go. So what are the steps to solve a first order linear ODE in one dimension? Well, I guess maybe I should have mentioned this right away. The first step is make sure that y prime is all by itself on the left hand side. Everything else is pushed to the right hand side. So you divide by its coefficients, you make sure everything else is on the right hand side. But from that point onwards, you find an antiderivative of m, lowercase m, you just call it capital M. You calculate an antiderivative of e to the minus m, f, call that capital F, and then you get your solution. So it's like 3 steps, and there's your solution. So let's look at an example of this. So there's a nice example, x squared y prime plus xy equals x squared, and we want to put this in the form y prime equals mxy plus f of x. And so to do that, I'm going to divide by x squared. That's going to get rid of that. It's going to make that a 1. It's going to make that a 1 over x. And then I'm going to move this term to the right hand side. So upon doing those, I'm going to recover y prime is negative 1 over xy plus 1. And if I'm clever, I interpret this as m of x. And so I compute its antiderivative as the antiderivative of negative 1 over x is negative log x. And then if I follow my steps, let's jump back here. So capital M is negative log x. I find an antiderivative of e to the negative log, e to the negative log x times m, which was just 1. Well, that's e to the log, which is just x. This is the antiderivative of x dx, and so I get x squared over 2. And then I produce my solution, e to the negative log x times c plus x squared over 2. And what do I get? I get, that's negative log x. That's 1 over x by log rules. If you don't believe me, we'll talk about it in class. And 1 over x times c, so I get c over x plus x over 2. So there's the solution, the general solution. Let's see if I was right. Then you see me move it to the right, and negative log, we get x squared over 2. So the solution is, yep, exactly, c over x, and then x over 2. That's our general solution. We'll go through one more example, and then we'll be done for today. So it's a very easy lecture today. Hope you appreciate that. So we have another first order linear ODE in one dimension. We're going to do the same stuff to convert this to y prime. It looks like I would get something like negative cotangent t times y plus t. T over sine, which I guess is t secant? No, t cosecant. T. Okay, so that's what it would convert to if I take an antiderivative of cotangent. We'll just go through you all have Wolfram to help you out. So if I take an antiderivative of cotangent, I get negative log sine. If I take the exponential of that, the negative version of that multiplied by cosecant, I just get t, and so that will give me t squared over 2, which gives me that the solution is c1 cosecant t plus t squared over 2 cosecant t. And that's all there is. Thank you very much. Bye.